Alright, boys. Let's get this started. Also, I'm filming this while y'all are at the AJR concert, so let that sink in. I'll be doing the evens per usual, starting on page 81, 2.8, solving word problems, not world problems. But in order to solve world problems, you need to solve word problems. So, question 2. 3 automobiles at 32,896 each. So let me start by saying it says to find the value of each. So we need to set up a word problem. So let's write down what we got. We got 3 automobiles. Let's use A for automobiles. Why not? And A can equal the price of each automobile. Let's just say price of car. So if we have 3 automobiles, and the price of each car is $32,896 each, all we got to do is a substitution. A equals 32,896. Sub that in over here. 32,896. You bada bing, bada boom. Got a 98,688. What does this tell us? This tells us that if we bought 3 automobiles for this price, it would cost a total of that much. Wow. Basically, all these are multiplication word problems. So for number 4, if it says, if we have x minus 9 quarters, how much money do we have? Well, so x minus 9 equals the number of quarters. That's what the problem tells us. If 1 quarter equals 25 cents, and 2 quarters is 50 cents, and 3 quarters is 75 cents, what's happening for every quarter? Each quarter is 25 cents, which means whatever number we have, we just multiply by 25 cents. So if we have this many quarters, all we got to do is multiply that by 25 cents, just like everything else. X minus 9 times 25 cents. Now, if you wanted to, you could distribute, and you would get 25 x cents, and then whatever 9 times 25 is would be $2.25 if you wanted, but this is nicer right here. It's all nice and compact. Yeah, great. For question 6, it's the same thing with dimes. So what do you think we're going to do? Instead of multiplying by 25, we're going to multiply by 10 cents. So I'll go ahead and skip that one. Number 8, 5 more than 3y. So let's just start there. 5 more than 3y at 88 cents each. What does this question mean? It's weird. It is weird. Y is our object. We're trying to figure out how much the price if we have 5 of a certain object plus 3 times some other object. And they all cost 88 cents each. We don't need to know what it is. All we need to know is how to convert this English sentence into a math sentence. So if we have this many objects, and they're 88 cents each, what did we do all the other times? We multiplied our number of objects times our price of each object, price of object. So we have this many objects times 88 cents each. There you go. That's all you got to do. If you want, you can distribute. This is the same as distributing from the left. If you have these two things are the same. Only when it's being multiplied with the explicit little doohickey right there. Anyway, number 10, y less z cookies at 80 cents each. Well, how many objects do we have? We have y less z. Less is just a fancy way of saying minus z cookies. So this is our number of objects. And how much is each cookie? 80 cents. So we just multiply by 80 cents. But I'll put it in dollars this time. How do we write 80 cents in dollars? We put $1.80. Yeah. Anyway, those problems were kind of weird. The point is, find out your number of objects, turn your English into math, find the number of objects, and then just multiply by the price per each object. Yeah. Okay, questions 11 through 26 are all word problems. and you're just they give you some instructions, and you're just gonna turn the English into math and figure out the problem. Kind of obscure, but we'll take a look at the even ones and see what we do. 12. Separate the number 27 into two parts, so that the first number is twice the second number. What are the numbers? Now, it's a little ambiguous meaning there's not a clear direction. But what they mean when they say separate into two parts is two numbers added together equal 27. So let's start with that. We don't know what the numbers are yet, so let's just make up two numbers. Or not make up, let's use our variables. X plus y equals 27. So the first part of the problem says separate the number 27 into two parts. Okay, we did that. One number plus another number equals 27. All right, what does the second half of the sentence say? So that the first number is twice the second number. The first number, x, first number equals twice the second number, right? And exactly how it's said in English. So we got two problems here. That's good, because now we can use, when we have two problems like this and two variables, xy, we can use substitution. So we see that x equals 2y. So let's do a substitute. Instead of writing x in the left, we'll write 2y plus y equals 27. What do we got? We got 2y plus y, which equals 3y equals 27. How do we get y by itself? Divide by 3. Divide by 3 on both sides. Cancel. We got y equals 9. All right, so we know one of our numbers equals y. What is the number? What does our second number equal? Well, we can do it two ways. We can either substitute it up here in our second equation, which is what I'll do in this case. So x times 2 times our y we know is 9 now. What's 2 times 9? 18. So we know that our first number is 18, our second number is y, and this is special because they make both of our sentences true. So 9 plus 18 equals 27. Okay, that's our first sentence. And then 2 times our second number, 2 times 9 equals 18, which is our first number. It checks out those sentences. That's what we mean when we do problems like this. We're trying to find the values of our two variables that make both our sentences true. 14. One number is 25% more than another number. Okay, so percents. I might need to make a video about percents again to just review it. But if something is 25% more, let's just start with that first sentence. One number is 25% more than another number. So if we just write 25% of a number, of means multiply, of another number, this just says x is 25% of y. That's not what our sentence says. It says one number is 25% more than. So in order to be 25% more than, we got to add that 25% back on top of our original number. Just like think of an example you already know. If you have $100 and you want 10% more than $100, you don't just take 10% of 100, that would just be 10. You take that 10 and you add it back onto the 100. 10% of 100, or 10% more than 100 is going to be 110. You take the percentage and you add it back onto the number you already had. So this is our first sentence right here. One number is 25% more than another number. The sum of the numbers is 135. So the sum means add. The sum of our two numbers is 135. Great. All right, we got two sentences. Let's go ahead and do a substitution. X equals 25% y plus y. So we could replace, let's go ahead and replace x in our second sentence with that. So instead of writing x, we'll write 25%. And instead of writing a percent, let's go ahead and switch that to a decimal. Move our decimal point twice. 0.25y plus y. See, we substituted our x. Plus y, everything else stays the same, equals 135. All right, we got 0.25y plus y plus another y. So we do our parentheses first. What's 0.25y plus 1y? Well, we get 1.25y plus y equals 135. What's 1.25y plus y? Gives us 2.25y equals 135. And then to get y by itself, we divide by 0.25, divide by 2.25. Ha, you thought you caught me. I caught myself. Yeah, that's fine. Another way we could do that, a more fun way, I'll go ahead and show you. Let's turn that decimal into a fraction. What's 2.25? What's 2.25 is a fraction? 2 1/4 y equals 135. And we don't like mixed numbers around here. We like improper fractions. So let's turn that 2 1/4 into 9 1/4. So how do we, right now, y is getting multiplied by 9/4. We undo that by multiplying by the reciprocal. What we do to one side, we'll do to the other. Cancel, 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 cancel. Can 135 and 9 cancel? What's our rule for divisibility by 9? If all the digits of a number add up to 9, we can divide by 9. 1 plus 3 is 4, plus 5 is 9. So 135 is divisible by 9. 9 goes into 9 once. 9 goes into 135 15 times. 15 times 4 is 60. So we got y equals 60. And if you're confused about that divisibility trick, I will make a video about divisibility. So we got y equals 60. We got to plug it back into one of our problems and figure out what x is. Let's go ahead and use our x plus y equals 135. We know that y is 60. Use our parentheses. It was 135. Right now, x is getting added by 60, so we undo it with subtraction. What we do to one side, we'll do to the other. X equals something. 75. Great. All right. All right, 16. A number is 25% less than another number. Okay, fraction, percents again, but this time the other way. A number is 25% less than, so 25% of a number, but if we're less than, we're taking away from our original number. 25% less than our original number. The difference between the numbers is 22. So difference, a number minus another number equals 22. Now, order matters with subtraction. Which number is the bigger number and which one's the smaller number? Well, let's see. X is, what does our sentence say? X is 25% less than. X is less than our y. So y is bigger, so we got y minus x. All right, let's do our substitution again. We see that x equals y minus whatever. So let's substitute, only replacing the x. Y minus, let's switch it to a decimal again, equals 22. And now our first step, well, yeah, let's do our parentheses first. Y minus, we got 1y minus 0.25y, that gives us 0.75y equals 22. And then we got our negative to distribute, y minus 0.75y equals 22. 1y minus 0.75y gives us 0.25y equals 22. And to get y by itself, let's convert that. Let's take it up here. Whoop, that's a dumb arrow. Let's convert that decimal to a fraction. We got 1/4 y equals 22. To get y by itself, we multiply by 4. What we do to one side, we'll do to the other. Cancel, y equals 44. And now that we know, 88. Nice try. And now that we know that y equals 88, let's go ahead and plug it into our easier equation. Y equals 88 minus x equals 22. X is getting added by a positive 88, subtract 88. That's going to give us negative x equals negative 66. Divide by a negative gives us x equals 66. Woohoo! So we got our two values. Remember, what this means is these are the only two values for x and y that make both of our sentences true. My battery's about to die, so I gotta plug it in. My laptop, I gotta plug in my laptop. All right, it's 18. Ariel, who is 15, so let's start with that. Ariel is 15. Now remember, A doesn't equal Ariel. A equals the age of Ariel. It has to be a value. So A equals the age of Ariel. So age of Ariel is 15. Ariel is 3 years more than twice the age of Hillary. The age of Ariel is 3 more than twice the age of Hillary. Okay? How old is Hillary? Well, what do? We only have this. Wrong. We have two sentences. Anytime we have two sentences, well, not anytime, but most of the time, we can use our substitution. Replace A with 15. 15 equals 3 plus 2h. We can do this because we only have one variable. What's happening to our variable? Being multiplied by 2 and added by 3. How do we undo addition by 3? Subtract 3. What we do to one side, we'll do to the other. What we're left with is 2h and 12. And what number multiplied by 2 is 12? The age of Hillary is 6. The age of Ariel is 15. That one's an easy one. 20. The debate team participated in 18 debates. It won twice as often as it lost. So, the debate team participated in 18 debates. D is the number of events the debate team participated in. Always has to be a number. D doesn't equal the debate team. It equals the number of events the debate team participated in. Always has to be a value, not a noun. It won twice as often as it lost. So, the number of wins, it is twice the number of losses. It won twice as many times as it lost. Now, what's going on here? We have three variables, right? Well, we have to come up with a total. D is the total number of events the debate team participated in. And the total number of events consists of all the wins and all the losses. So our D, the total number of events, which we know is 18, equals the total number of wins plus the total number of losses. Sometimes you'll come up with problems where it's something like this, and you're like, what? I have three different variables. I need two sentences with the same variables in order to make this work. Usually it's going to come down to a total. Where do we get D from? The total number of events the team participated in is the total number of wins and losses. You got to use your brain. Math's a thinking game. So now we got two sentences. We got W equals 2L and 18 equals W plus L. So we can do substitution. We know that W equals 2L, so let's substitute in our other sentence. 18 equals 2L plus L. 18 equals, what's 2L plus L? 3L. How do we get L by itself? Divide by 3, divide by 3. L equals 6. What does L mean? L is the total number of losses equals 6. How do we find out the number of wins? Let's substitute over here. W equals 6. 2 times 6 is 12. So the debate team had 6 losses, 12 wins, and if you add 12 plus 6, that gives us our total number of wins, 18. 22. Jordan has T coins in his pocket. So J equals the number of coins Jordan has. It doesn't equal Jordan, it equals the number of coins he has. It's important that you get your variables right. Write it down if you need to. J equals the number of coins Jared has. Jordan has. I'll call him Jared. And that equals T, okay? He has in nickels. He has in nickels. All right. I'm getting confused myself, but bear with me. If he has twice as many pennies as nickels, thinking, and 3 more nickels than dimes, how many coins does he have? Sounds confusing, right? Yes, I'm confused. Let's think about this part by part. All right. T equals the total number of coins Jared has in his pocket. Now, just like before, where we had to come up with a total of something, these total number of coins equal the total number of nickels, pennies, and dimes in his pocket. N means the total number of nickels. P means the total number of pennies. D means the total number of dimes. Okay, great. We have one sentence down. All right, totals. If you're missing information, come up with totals. That gives you an extra sentence. If he has twice as many pennies as nickels, so he has twice as many pennies. Wait. Sometimes you got to rephrase it. Then he has twice as many pennies as nickels. The number of pennies he has is twice as many as nickels. Wording's very important. Pause and think. I almost messed up. All right. And 3 more nickels than dimes. The number of dimes he has or the number of nickels he has, 3 more nickels than dimes. The number of nickels he has is 3 more than the number of dimes. All right, great stuff. Now, you may be thinking, oh my gosh, this is so much more confusing. What's the question? How many coins does he have? So that's a question of T. We want to find T, which is the number of coins Jared Jordan has. So it would be nice if we could get all these variables the same, wouldn't it? And let's see if we can find the variable that's in common. We got an NPD here, we got a P and an N here, and we got an ND here. What's in common? We got an N in all of our problems. So let's take a look. Let's do a substitution. Let's replace P with 2N. What do we get? We get T equals N plus 2N plus D. All right, that's great. That's cool, I guess. We've got 2 of our variables in, but how do we make this last one D? Or how do we get this last one to be a nickel? Well, remember whatever lesson? 2.7, I think. No, it might be this lesson. I don't know. No, it's 2.7. Remember, how do we have to get D by itself in order to make a substitution here, right? But all we have is this sentence. How do we get D by itself? Well, how do we get any variable by itself? We wonder what's happening to it. What's happening to D? It's getting added plus a positive 3. How do we undo a positive 3? We subtract a 3. What we do to one side, we'll do to the other. Cancel. What are we left with on the right? A D. What are we left with on the left? Read it to yourself. N minus 3. Rewrite it. N minus 3. We can't combine those things. Look, we got D by itself. We can make a substitution now. Total equals nickels plus technically pennies, but we made a substitution, plus technically dimes, but we made a substitution. All right, how does this help us? Let's simplify. Let's distribute our signs through. N, positive times 2n gives us positive 2n. Positive times n gives us positive n. Positive times negative 3 gives us negative 3. What's n plus 2n plus n? That's 4 n's minus 3. Now, you might be saying, what's the point of all this? Gee, that seemed complicated. Right now it kind of is, but what's nice about this is instead of having to have 3 different values to figure out the total number of coins in his pocket, we've written it in a sentence that only uses 1. The less information we need to come to a conclusion, the better. That's what all this is about. We want to simplify things, because if this is, I don't know, maybe this is a real life situation. We want to figure out the total cost of something. Well, in this scenario, you would have to find the total cost of the labor and the parts and the time. But if we simplify it, we only have to know one thing now. Knowing one thing is a lot easier than knowing 3 things. Anyway, that's my rant. But just think about it. It'll grow on you. All right. All right, questions 24 through 26 involve rates. I still haven't put out a rate video for you. I will, though. That still doesn't mean you can skip question 23 about rates. Still want you to try it, see if you can figure it out. I need to make a video about rates, is the point. Okay, let's do some quick simplification at the bottom of page 82. Number 2, let me write it on Paul. Here we go. All right, PEMDAS, parentheses. Technically, we like to treat the numerator and denominator as parentheses, so we'll start there. So rewrite everything we're not going to touch, plus what is 2 minus 8, negative 6, over, can't do anything with the denominator. Great. All right, PEMDAS. E, exponents. We got an exponent right there. What does it say? Now, remember, there's a difference between negative 5 squared and negative 5 squared. So in this case, the exponent only applies to the 5. So what is 5 times itself twice? 5 times 5. So we're just replacing that part. The negative stays because the negative did not get included in the exponent. Rewrite everything we didn't use. All right, great. Got any multiplication or division? Yes, we got some right here. What's negative 6 divided by negative 3? Well, let's start with 6 divided by 3. That equals 2. And the negatives cancel each other out. So we're left with negative 25 plus 2. Negative 25 plus 2 is negative 23. All right, over here. PEMDAS, starting with the innermost parentheses. So rewrite everything that's not an innermost parenthesis. When we come to our first one, what's 4 minus 2? 2. And we come to our second one over here. What's 5 minus 4? Negative 4. Great. All right. Let's do some multiplication, or we're still inside the parentheses technically. Negative 3 times 2. Let's do our distribution over here first, since there's technically still a parenthesis. What's a negative times negative 4? That's just going to be a positive 4. All right. We still got our parentheses. What's 3 times 2? 6. What is 2 plus 4? 6. All right. Now we got a negative and multiplication over here. So what is 6 times 6? 36. Keep the negative, and bam, negative 36. Is that right? Yes. Okay, great. All right. Number 6, negative 6 plus negative 2. Let's distribute first. What's a positive times negative 2? Negative 2. What's negative 6 minus 2? Negative 8. We got negative 6 times negative 2. Start with 6 times 2 is 12, and 2 negatives make a positive, so just positive 12. Over here, we got negative 2 times negative 4 times negative 3 times negative 3. Let's start with 2 times 4 is 8, and our 2 negatives cancel out, so that just becomes 8 right there. 3 times 3 is 9, and our 2 negatives cancel, which just give us 9. 8 times 9 is something, probably 72. And to finish this off, negative 2 times negative 4. What's 2 times 4? 8. The 2 negatives cancel. What's negative 5? What's 5 times 3? 15. The negative stays, so we'll write negative 15. And now let's distribute that positive. What's positive times negative 15? Negative 15. 8 minus 15 equals negative 7. And over here, we got absolute value. Remember, absolute value kind of acts like a parenthesis, so we'll do that first. What's the absolute value of 3? Negative 3. It's 3. Rewrite everything we didn't use. Let's distribute that positive. Positive times negative 8 is negative 8. We got 6 times 3 minus 8. 6 times 3 is 18 minus 8, and 18 minus 8 is 10. All right, that's the lesson. Remember to write down your questions so you can ask me during car math. I'll see you in the next video. Bye.